Good evening, everyone. So now this is the welcome to the Mathematics Rose channel, and now today we are going to explain the geometrical representation of the complex number. This is the lecture 7. So now representation of complex number. First, we can represent the complex number in geometrical form. Geometrical representation of a complex number suppose z, which is in the form of x plus iy, so now here Argand plane or we can say complex plane, or we can say Gaussian plane. The plane in which C set of complex numbers is represented is called Argand plane or Gaussian plane, or it is also known as complex plane. It consists of x dash axis called purely real axis and y dash axis called purely imaginary axis. In x dash axis, we represent real number or complex number also, but where the imaginary part x plus iy, where y is equal to 0, means it is equal to x, so this becomes x. So x means all the real numbers. X belongs to all the real numbers, and in y dash axis the complex number is equal to iy, since here x plus iy and x is equal to 0, so it becomes iy only. So in this axis, y dash axis, we represent only I, 2i, 3i, 4i, and so on, and minus I, minus 2i, minus 3i in the negative side. So now, first of all, just drawing an Argand plane or Gaussian or complex plane. X dash taken and y dash. So here I am taking 1, 2, 3, 4, and so on, minus 1, minus 2, minus 3, minus 4, and so on. So this lies between minus infinity to plus infinity. So all the numbers lying between minus infinity and plus infinity are real numbers, and all the real numbers are also complex number because they can be expressed in the form of x plus iy. And here I am taking this distance is I, this is 2i, 3i, and so on, and here minus I, minus 2i, minus 3i, minus 4i. In general, iota is not written, but here I am writing only to explain you. You can remove it. So suppose in the first quadrant, we know that both coordinates are positive. So if we will take here 2 and here is this point, we will get the perpendicular 2. As a 2, so we will take perpendicular over here, and we are getting a point A. Its coordinate complex number is also an ordered pair of the two real numbers. So it is 2 x coordinate and y coordinate 3, but y coordinate always represent purely imaginary number. So this is 2 plus iy. This is the representation of any complex number in Argand plane. So here in the first quadrant, all real part as well as imaginary part will be positive. Means x is positive. Suppose z is equal to x plus iy, then x is also greater than 0 and y is also greater than 0. Suppose I am taking here P is any point whose coordinate is x and y, and then here from here we will just draw a perpendicular, and I am just joining OP, and here the put of perpendicular is M. So OM is equal to x and PM in the direction of y axis. So it is, suppose that it is y. If we will take the x comma y, it is the ordered pair of the two real number x comma iy, which represent the complex number. So x plus iy. So here, see, if we will go in this direction, in the positive direction of x-axis, OM is equal to x, and then perpendicular to x-axis, and we go along y-axis, and y distance we travel, we will get the point P, which is point P whose coordinate is x and y, where x and y is the ordered pair, and which represent a complex number which is x plus iy. It is in a standard form. So now here we are getting which type of triangle? Right angle triangle. So suppose if we know this distance is r and this angle is taken as suppose alpha. Alpha is there. Alpha is the positive angle. Suppose alpha is positive angle because it is formed in anti-clockwise direction, and if we know the alpha positive angle and r unit distance, if you know, then making an angle alpha, and if we will travel in this direction from origin to the point P, r units, we get the point P. So it is r comma alpha. This is called the polar coordinate of complex number. This, and complex number here is z. So now see here, I am writing in triangle POM, angle PMO is equal to 90 degree, and P having the coordinate x comma y, representing a complex number x plus iy, x plus iota y, and if it is in the first quadrant, second quadrant, third quadrant, and fourth quadrant, any quadrant. So here I have just given it is in the first quadrant. So P r comma alpha, it is the polar coordinate of z, means complex number z belonging to C. Now here we will just take the relationship. So the relationship between the Cartesian, this is the Cartesian coordinate, of z. C means set of complex number. So now see here, r square is equal to OP square is equal to OM square plus PM square. So it is x square plus y square. So r is equal to root under x square plus y square. And now we know that z is equal to x plus iy. Therefore, modulus of z is root under x square plus y square. Therefore, we can write r is equal to modulus of z, which is equal to root under x square plus y square. Now we will get a relationship between r and x and y. So this you can find out very easily. And now here I am writing in the same triangle POM. If we will take sine alpha means perpendicular by hypotenuse OP. So perpendicular is y, hypotenuse is r. So sine alpha is equal to y by r is what? Root under x square plus y square. So this is the relation is coming. And similarly, cos alpha is also, it is base by hypotenuse. So base by x square plus y, root under x square plus y square. So this. And now if the complex number lies in the first quadrant, then alpha is acute angle. If the complex number lies in the first quadrant, then the alpha is acute angle, and alpha is the angle which is formed in anti-clockwise direction, and any angle which is formed in anti-clockwise direction in trigonometry of class 11 first chapter says that these angles are positive angles. So here alpha is positive angle and this alpha is called argument of the complex number z. So if we have to find here the argument, we will also use one of the formula. Tan alpha is equal to perpendicular by base, so y by x, and you will have to take mod of this. I will explain in the next page. In the next page, how to find the argument if the complex number lies in the second quadrant and if the complex number lies in the third and fourth quadrant. Suppose here I am representing from 3, I am just drawing a perpendicular along y-axis, and from this 2i, I am just drawing a line which is perpendicular to y-axis and parallel to x-axis. We are getting, suppose, a point B. Now its coordinate is -3 and only 2 we will write because complex number is the ordered pair of the two numbers. Now this represents a complex number 3 plus 2i. This is the representation of a complex number, and this plane is called Argand plane or a Gaussian plane or a complex plane. So now here what we see, x is equal to -3 and y is equal to 2. So here x is less than 0 and y is greater than 0. So in the second quadrant, x is x छोटा है 0 से और y जो है बड़ा है 0 से. So if we will join this point here, so this angle is also a positive angle, and if we know this angle, what is the measure of this angle, then we can find out the argument of this complex number. And this angle is obtuse angle because it is more than 190 degree and less than 180 degree. So we can prove in trigonometry this alpha angle is equal to this also, and this is also alpha. So we can just subtract from 180 degree because this is 180 degree. So if from 180 degree, if we will subtract alpha, then in the direction of anti-clockwise direction, we get an angle which is in the anti-clockwise direction, which is positive angle, and that angle is also, that angle is 180 degree minus alpha will give the argument of this complex number. So suppose we have to find the argument of this complex number, then we have to use the formula. Suppose this is z, then we have to use the formula 180 degree minus alpha. So we will use, if a particular complex number lies in the second quadrant, then argument of the complex number can be determined by applying this formula 180 degree minus alpha, where alpha is the acute angle which is related with the tan alpha is equal to modulus of y divided by x, and we will find out the acute angle alpha, and we will subtract from 180 degree, and after subtracting from 180 degree we will get an angle which is in degree, and then we will multiply by pi by 180 degree, then we will get in the radian form of argument in radian form. So suppose that I am taking a perpendicular taking from -2 and then taking from -3, so we will get a point. Suppose it is R, so its coordinate will be x coordinate -2 and y coordinate -3, so it is representing -2 -3i. So here if you will compare, x is equal to -2, y is equal to -3, so x is less than 0 and y is also less than 0. So this represent a complex number, suppose z, where both coordinates x and y both are less than 0 because both are negative. So here what will happen if we will join over here? So this is the representation, and if we have to find this is the origin, and origin is also a complex number. 0 plus 0 we can write, because origin represents 0, and 0 is a complex number which is a purely real complex number. It is not imaginary number, because imaginary part is 0 and real part is also 0. So 0 is a real purely real complex number. If we will join this r with this, we can show that this angle will be this angle, this will go this side. Suppose this angle will be acute angle alpha, then here is 180 degree, and if we have to find out the argument of this complex number here, argument of this complex number, suppose ARGZ, argument of the complex number, then we have to choose 180 degree plus alpha. Or if we go in this direction, in clockwise direction, suppose I am coming from this direction, so what will happen here? We see that this is not this is the negative angle. This is negative angle, but it is less than 180 degree. And how much? This is alpha. So this can be written as 1 minus 180 degree minus alpha. So from this we can find out, from this formula we can find out the argument. Both are the argument of the complex number, because this is only negative angle and this is positive angle, the whole thing. So here you just see that if we will just draw this angle, this is the positive angle, and if we will go in this direction, this is the negative angle. Both are argument of the complex number z. So we can find out here this. So if you will, I am taking over here, I am taking this, drawing this. So it is the complex number 2, and here the coefficient of minus I means minus 1. So this represents a complex number 2 minus 1i. Okay. So here x is equal to 2 and y is equal to minus 1. So x is greater than 0 and y is less than 0. So it means that in the fourth quadrant, what will happen? This is in the third quadrant. In the fourth quadrant, what will happen? We see that the complex number, the real part is 0 and coefficient of I is negative. So here, if we have to find out the, if we will join over here, so it will become a tedious type of work. So I am not writing over here. Only I will tell you that what will be the argument of the complex number. So in this case here, the argument will be, if the complex number lies in the fourth quadrant, then we can find out the argument by 360 degree minus alpha, using the 360 degree minus alpha, and excuse me, or we can simply 360 degree minus alpha, or simply we can take minus alpha. So this formula will be applicable over here, because if we will take the negative angle, then this minus alpha will come, and then for positive angle 360 degree minus alpha we will get. So in this way we will get the argument of each complex number lying in first quadrant, second quadrant. If the complex number lies in the first quadrant, then the argument is acute angle. If the complex number lies in the second quadrant, then the complex argument will be obtuse angle. And if the complex number lies in the third quadrant, then the complex then the argument will be more than 180 degree, and if it is taken in the negative side or clockwise direction, then it will be less than 180 degree but having negative sign. And if the complex number lies in the fourth quadrant, it means that the complex number the argument will be 360 degree minus alpha, or we can find or minus alpha. Minus alpha means negative angle. So in this way we will find out the argument of the complex number. So I think it is clear, because the less so many things we have to write. So how to represent the complex number I have explained over here, and how to find the argument of the complex number. So we can draw the diagram, and as well as we will find out the argument of the complex number. First of all, we will have to change the complex number in a standard form. Then only we can find out the complex number with the help of this. Okay, so I think it is understandable to you. Now the problems. Suppose the first question I have taken: find the modulus and argument, or it is also known as amplitude of the following complex numbers first is 1 plus iota root 3, second minus 2 plus 2 iota root 3, third minus root 3 minus iota, fourth 2 root 3 minus 2 iota. So here we will have to find out the amplitude as well as argument of the complex number. So now this is the first question of this video, lecture 7. So now solution. Let us suppose first question, let us z is equal to 1 plus I root 3, or this can be suppose in the form of x plus iy. It is already given, so no need to convert. So x is equal to 1 and iy is equal to I root 3. So I will cancel. So y is equal to root 3. So it is greater than 0 and 1 is also greater than 0. So x is greater than 0 and y is greater than 0. It means that therefore 1 plus iota root 3 lies in first quadrant. In the first quadrant में लाई करता है, और if we will use tan alpha is equal to mod y by x, then y is equal to here root 3 and x is equal to 1. So root 3 will come. So tan alpha is equal to root 3, and we know that root 3 is equal to tan 60 degree. Therefore alpha is equal to 60 degree into you will multiply by pi by 180 degrees, so it is pi by 3 radian. So it means that argument of this complex number z is equal to pi by 3. So argument is what? Alpha. Alpha is the argument because it is acute angle, because the complex number lies in the first quadrant. Now we have to find out the modulus. Modulus of z means r. It is equal to root under x square plus y square. You know, 1 square plus root 3 square. So it is root under 1 plus 3. So it is plus minus root under it is 4, so plus minus 2. So r is equal to this. So now if we have to find out the polar form, so polar form हम कर दे रहे हैं. Polar form, the polar form is equal to r cos theta plus I sin theta, and in place of theta I am just writing alpha. So here plus minus 2 model cos theta in place of alpha, alpha in the book it is written theta. So pi by 3 cos pi by 3 plus I sin pi by 3 pi by 3. So this is the polar form of the complex number. So if we will take over here, so now this is the answer. So second I am taking second number. So let it is z is equal to minus 2 plus 2 iota root 3, or we can write minus 2 plus 2 root 3 iota, and we will compare with x plus iy. So x is equal to minus 2, y is equal to 2 root 3. So x is negative, x is less than 0, and y is greater than 0. It means that the complex number lies, z lies in which quadrant? In second quadrant. In second quadrant, the argument is always obtuse angle. So we will find the first of all the modulus of the complex number. Modulus is equal to root under x square plus y square. So it is minus 2 square and then 2 root 3 whole square. So it is equal to 4 plus 4 into 3 root 3. So 4 plus 12. So it is equal to root under 16. So plus minus 4. So r is equal to mod z is equal to modulus is equal to plus minus 4. This, and now we will find tan alpha is equal to mod y by x. So y is equal to here 2 root 3 divided by minus 2. So 2 will cancel, and here we can write it is minus root 3, because it is minus 1 will come, so it is root 3. So it is tan 60 degree. So alpha is equal to 60 degree, but the complex number lies in which quadrant? In the second quadrant. Therefore argument जो होगा, argument is equal to 180 degree minus alpha. So 180 degree minus what? Minus 60 degree. So it is 120 degree, and now we will convert it in radian form. So 63 times to 2 pi by 3 radian. So in this way we can find out the argument. So hope it is clear to everyone. So now I am coming to the next question. Now say the third question I have written. here z is equal to minus root 3 minus I. So it means that here x plus iy form. So x is equal to minus root 3 and y is equal to, here coefficient of I is equal to minus 1. So both are less than 0. So it means that this z lies, complex number lies in third quadrant. Now we have to find first of all modulus. It is easy to find out root under x square plus y square. So root under minus 3 whole square and then minus 1 whole square. So it is equal to 3 and then 1. So it is plus minus 2. 4 होगा, 4 का स्क्वायर रूट 2 हो जाएगा. And now argument, we have to find the argument of z. Now first of all you will take every time tan alpha is equal to y by x mod. So y is equal to what? Y is equal to minus 1, x is equal to minus root 3. So minus minus cancelled out. Root under 1 by root 3. So it is 1 by root 3. So you know that cos 30 degree. So alpha is equal to 30 degree. But the complex number lies, this complex number lies in the third quadrant. Therefore argument of z is equal to 180 degree plus alpha. It means that 180 degree plus 30 degree, this is equal to 210 degree into pi by 180. 0 will cancel. 3 7 times 3 6 times, so it is equal to 7 pi by 6 radian. So this is the answer. This is the answer of in third quadrant. But one more argument we will get, because one is 200. To suppose this is 180 and 30, so it is 200. Up to this it is 210 degree, and in this way if we will find out, so it is 360 degree minus 210, so it is 150. But in which direction? In the clockwise direction. So it is equal to minus 180 plus alpha. This is one of the formula, minus 180 plus 30. So it is minus 150. See here, it is minus 150. Here I am writing minus. Why minus? I have to put because of the angle is formed in clockwise direction. Therefore, so minus 150 into pi by 180. So 0 cancel. 3 5 times, 3 6 times. So minus 5 pi by 6 radian. So hope the argument of z here is equal to 7 pi by 6 and second is minus 5 pi by 6. These are the two answers of this. If the complex number lies in the third quadrant, so we can find out the two argument you will get. So now we are coming to the next question. Next question is fourth one. Fourth one is fourth one, z is equal to, suppose let z is equal to 2 root 3 minus 2i. This, so we will compare it. X plus iy, x is equal to 2 root 3 and y is equal to minus 2. So y is less than 0, x is greater than 0. So it means that z lies in fourth quadrant. Z lies in fourth quadrant of the Argand plane. So here first of all modulus of the complex number, which is equal to root under x square plus y square. So it is 2 root 3 whole square and then it is minus 2 whole square. 2 root 3 means 4 into 3 plus root 3 and then 4. So it is again 16. So it is plus minus 4. So the modulus of the complex number is plus minus 4. in general we will take only positive sign. So because the modulus represent a particular distance of the complex number, so you have to take only positive sign. So here where I have written the negative one, you will just write only positive sign. So now we have to find the argument of the complex number z. So here argument we have to find. So tan alpha, tan alpha is equal to mod y by x. So y is equal to what? Minus 2 and x is equal to 2 root 3. So it cancels one time. So it is minus will become plus. So it is 1 by root 3 and this is equal to tan 30 degree. So alpha is equal to 30 degree, but the complex number lies in which quadrant? In the fourth quadrant. Therefore, argument of z is equal to 360 degree minus alpha. You will have to use this formula, 360 degree minus 30 degree. So 330 degree into pi by 180. 0 will cancel. 3 times 11. 3 6, so 11 pi by 6. This is one of the value of the argument. So argument of this complex number is 11 pi by, I think it is visible, not visible to you. Now it is visible. So 11 pi by 6, and now the argument second you will find out minus alpha. Directly you will write. So because the negative angle, because from the two angles we can go to that particular point. So but in the first, suppose that the complex number lies in the first quadrant, the other angle is a reflex angle. So no need to find out that also. Now here it is minus and alpha is 30 degree, and now minus 30 degree into pi by 180. So it is 0 cancel. 3 6 times, so minus pi by 6 radian. Therefore argument of the complex number z is equal to 11 pi by 6 and minus pi by 6. Okay, so this is the answer. There are two arguments of the complex number. So hope you will understand it very well. If anybody any type of difficulty, please like, subscribe and share my video. Nobody is subscribing, most of them, and also not pressing the like button. Please press the like button, as well as please press the notification icon button so that you will get the notification, because suppose any day I will be not feeling well, only that day I am leaving not to make the video, but regularly I am making the video, and in each topic I am going from the basic to the advanced, and then I will go to IIT main question as well as IIT advanced questions also. So do not think that I am not going to explain those things. I am just restricting myself in class 11. It will not be done, because I will have to work hard. You will have to also work hard and see each and every video with pen and paper also, copy also, and do whatever. And I am not telling you that you will also see the others video, those whose presentations are very good. You just you also watch that video also. I am not telling that because of the resources, because suppose that anybody is writing in the 2 lakhs board, so their writing skills and everything will be very good, no doubt. So resources is a different thing, but the content what I am giving, you must see. If the content is not good, please comment to me so that I will rectify or improve myself. And comment also, please see and please view the whole video completely, completely, so you will understand, because it will help to your basic as well as internal examination also, internal examination as well as in final examination in IIT. IIT it will help. So do not think that it is only for the purpose of class 11. I am just writing class 11. When I will start teaching the, after completion of every chapter, every chapter I will teach the IIT mains questions also. So do not think that I am not going to teach it. Okay, thank you. Bye bye, and please take care of yourself, and please follow the instruction. It is not I am giving the instruction, but it is my kind request. So please like, subscribe as well as share. I want to see that how many of you are just subscribing my video, and how many I will see tomorrow. Tomorrow, today, right now I will release the video. Okay, and it is the time is 12:30 at night. So please